Hello everyone, my name is Tianchun Wang, in a team called T-Beam, like a one-man team. Our first stop was Finfrock Industries. It was a professional industry, as we thought it is going to be our big beam project plant. And in the first picture, we can see all the factory's walls and ceilings are precast concrete. They use double T beams in the ceilings, and on the platform they are making frames for precast wall. I think they are following very strict rules here, and the rectangular frames are for the windows in the walls. Here's a complete product ready to transport, and then we went to another factory. They are making another type of prestressed concrete product. Here are some prestressed, already pre-tensioned tendons and frames. One of the most amazing things in the in the tour I found is that they are using lasers shoot from the ceiling to locate the positions of the tendons and the rebars. It really makes the procedure more accurate and efficient, I think. And they can only just control these lasers from a tablet, I think. Then we went to Coreslab structures. They mostly make hollow core prestressed precast concrete beams. In the factory, they are using these machines to for pre-stressing, and here are some platforms and tendons are ready to use. The most amazing thing of this factory is this system they are using. Here's the machine to pour and shape the concrete into the beams they wanted, and there are no frames to use, so it's very easy to operate, and they even don't need to stop the process to add concrete, because there's a barrier on the rails to add concrete to the machine during the machine working automatically, and it is very efficient. So surprised. And then I found the beam curing and hardening, and on the end of the factory they can cut the beams into the lengths they need. Then we went to the storage of the factory. These are the complete products ready to transport, and we can see the strength in the cross section. I think this tour is very meaningful because we can find a lot of things we learned in the book, in the class, that what they looked like in the real life, and how they were applied. The last stop was the Dura-Stress. They usually make the very large-scale products, like this one is a very long rectangular beam. These are the pre-tensioned tendons for this beam, and here are some completed products on the background. Also, this one is a pre-stress machine for I-beam. They can adjust this part to suit the height of the beam they wanted, and also there are some completed products on the background. Then we went to a construction site. They are making, I think, frames for U-beam with curves. It's a very large U-beam. We can see the beam is also is taller than the workers, and we can see this part because of the very long length of this beam and its curves. This beam uses We can see the complete product here, and with post-tension tendons. And these are two questions I asked, and they answered. First one is pre-tension or post-tension for small products or any other ideas they can use in small products. The Finfrock said, engineers from Finfrock said that they usually use pre-tension and straight tendons in most of their products, not only in the small products. And how to make sure that
that's what you saw, right?
Yes,
right?
And most of them they barely use halved or trapped.
It's much easy to make.
Yes, and cost less, I think. So how to make sure that products meet strength requirements, and what happens if they don't? There are restricted rules to make sure products meet requirements, and there are always inspectors to check every step and every product. If there is a defective product, they have procedures to try to fix it. It is very rare to dispose a product. That's it. Thanks.
Any questions or comments? So then now you have a preliminary design. So what kind of section?
I reuse rectangular.
Rectangular.
Yes.
Okay, then what kind of the pre-stress you have?
Sorry, pretension.
You have pretension.
And hard.
Art, okay. So after your plant tour, then do you have any changes in your mind?
I tried straight.
You want to try straight?
Yes,
okay.
Constant intensity.
And then why you want to have a straight?
Now I don't know the cost. I want to compare the cost.
Okay, so after your plant tour, then you want to have a straight tendon?
Yes, I want to try that method.
And then what kind of problem you can expect when you have a straight tendon?
I'm a little worried if I use maybe same tendon, same concrete, they won't get the same strength.
Same strength? I don't quite understand.
Straight and halved,
Okay.
two methods, using same tendons, same concrete. But I'm a little worried that they don't have the same strength.
You mean the tendon? I think you can use the same kind of tendon, right? The same tendon you can use, but it depends on how you
Design
the reinforcement.
I mean,
But my question is, okay, then after your plant tour, that you found that most of the real work project
yes.
is when you have a pre-tensioning, then you have like a straight.
Yes.
I think that's the main reason that
Yeah.
you chose that.
I want to try that
You're
one.
thinking about that because this is not a final, and you still have a chance to modify. But at this time, you're more towards to the straight tendon.
Yes.
But what we have to worry about, maybe considering the straight and art, what are the things that we have to worry about? What is the main motivation to have an art tendon?
To reduce the moment at the midpoint.
Yes, so to reduce the moment at the supports, right?
Oh, okay. Yeah.
Right. So then that's something that we want to think about. Another thing is if you want to have a pre-tensioning, can Finfrock facility support art? And that's another thing that you have to.
Yes, I asked.
So then, what is their answer?
I added the question.
You added the question.
Yeah.
Okay, so then you don't know the answer yet. Okay. So then I think those will be the important pieces of information, right?
Yes.
So then when you have a large moment, it depends on how thick your beam, right?
Yes.
Depending on how thick that your end moment due to the pretensioning, right, will be decided. So then you will have a large moment at the anchorage. So
Yes.
then anchorage reinforcement will be important. So did you ask anything about anchorage reinforcement?
No.
That's something that you want to add for the questions, right?
Okay. Yes.
Are you going to stick to the rectangular shape?
Yeah, I think that is more easy to make, and I don't know the cost yet, but I think it can compare with these other shapes.
What determines the cost?
The volume of the concrete and the tendons.
Right. So then, if you have a non-rectangular shape, usually non-rectangular shape is a more optimal design, right?
Yes.
Compared to rectangular.
Mm.
I know that we have other groups has a rectangular design. So then, what is your motivation to have a rectangular shape?
Well, I think for us it came down to like trying to have a lighter section. We did notice like even the smallest like astronaut type 1B was almost like 300 pounds per foot, where the rectangular section we're using now is only 200 pounds per foot.
Yeah, but even we don't have to really follow the AASHTO because AASHTO is a very large, okay? So then we talked several times, but our big beam is not a really big beam,
Yeah, it's
right?
quite small.
So it's a small big beam, right? So then we can play with the shape and customize. We don't have to really follow the AASHTO type, AASHTO dimensions, right? We can have a customized design. Of course, we have to. That will actually give us a more close to the optimal design. And by doing that, you could have the same flexure strength, but you can have a cheaper design. So, but the thing is, one thing that we have to check is, can we make it?
That's what we were concerned with. We were trying to use standard shape just because we want to be able to build England. Whereas the custom shapes, we were like, I don't know if they can actually do what we want.
So those are the questions you guys have.
Yeah, it's in our sheet if they
Right.
like about 10 minutes and like can they do different shapes.
So what I'm going to do is after this presentation, then I think the main motivation of this presentation, you guys have now more detailed questions, right? So I'm going to invite the Finfrock engineer. So that we're going to invite him here so that we can ask those questions, right? So then they will tell us what we can do. Any
So
go ahead.
you mean with maybe I shape or inverted T shape will
Yeah,
be
something
more
like that.
will be more cheaper? I mean, more,
Yeah, because by doing that, we can reduce the cross section, which is cheaper. Right?
Okay, understand.
Another idea is material. So, is there any group who considers a different material? Okay. Lightweight concrete.
And I have a question about that in the presentation.
Okay, all right. So then we're gonna talk about that. But material is something that you guys also want to think about. Any other comment? Not yet. Don't feel pressure. So, any other questions? Do you have a question?
No, I asked you the shape, which one
Shape?
is more. You
And
think the other shapes will be cheaper, right?
Yeah, because idea is you want to have a same like a close, very close, the flexure strength at the same time smaller cross section. That is actually one of the primary way to reduce the cost.
I was just worried about if they don't make such a small side beam with I shape, double T, invert-T. So that's why I choose the rectangular.
Yeah. But it's too early to conclude.
Yeah, I know.
Before we ask.
So I added the question. Thank you.
Yes.
I guess I might need more of a question for them too. Like, would creating like our own cross-section, like customized cross-section, it'll be cheaper in materials, like I understand that, but what about like formwork? Making formwork for a rectangle, or I guess a standard shape,
Yes.
for them is probably cheaper than calling whoever they do to make their forms, make a custom form, just for us.
That's why we have to make sure that if the labor cost is included. So I know that you guys work for free. So, but I think if the labor cost is included, I think then standardized design it, no one can do it. Okay.
Yeah.
Right. So then I think considering the motivation of this competition is purely about the structural related. So that's my guess.
Yeah.
But I can ask them.
I just know like for that, making cost is a component.
Yeah, right,
to
right.
it and such. Is there a balance?
Right.
I have a question. During the competition, are they gonna evaluate all the cost that we spend, or they're just gonna evaluate the cost of the theoretical? I didn't quite understand the evaluation of cost.
Evaluation of cost. So then, like any civil engineering or construction project, there is itemized price, right, cost, and then you add up, and then this is how they come up with.
They're gonna assess the cost by measuring what we spent. Okay.
Your product, right?
Like the Finfrock is gonna help us to make that product in the Finfrock industry. That's
Yeah, I think we have a basic table with the guidelines. But if you use a special material, for example, or component, then you can get those information from here.
So they're going to spend money for us.
Spend money
For creating that shape, that product, part of it.
Yeah. This is actually the part of the deal that Finfrock actually donate those and provide those materials for you and facility to you. Thank you.
Thank you.
Good job. Yeah, please copy on the desktop.
Where do I get this? Do you guys know where to get this? You know where is the USB?
Yeah,
Do you
open
want
the
to
Explorer.
sign my email?
Yes, if you want. But it's changed, you know? You have to.
Yeah.
I don't know. Do you know where to get the USB? No, but like to open it because it's not.
Open up the Explorer.
Oh, okay.
Oh, you were asking that.
Yes.
And copy on the desktop.
Good afternoon, guys. Our name is Prex, and our group is conformed from Julio Moreno. Our first stop in our trip was Finfrock Industries, is the company where we're gonna design our big beam contest beam. Here, our first stop, we could see the hydraulic jack with what they applied tension on their beams and sections. After that, we saw different big wires. They usually use half-inch wires in there. After that, we were walking for the path. We saw some double decks that they use for construction of houses. They put the conducts and everything inside before installation. After that, we could see arrange some electro-welded wire mesh for reinforced steel on the sections. They had big story houses with overhead cranes on top to transport the sections, walls, and big sections within the story house, and to install to transport on the different trucks. Here we can see some other overhead cranes that they have outside to put the different sections on the trucks and transport. Some more of the overhead cranes that they have. Here you can see how they transport the different sections and put on top of the trucks. Here's a big section that they have, probably a wall. Here on the space of the story house, they have some hollow core planks, some prefabricated stairs, and some other sections that they produce on Finfrock Industries. Here they have the cement silos, where they have all the cement. They have the aggregates usually in different story houses, so they don't contaminate. Here's some more other materials that they have on the company, some molds that they use to create their different sections. While they're curing, some of them are pre-tense before applying the concrete. Here's the batch plant where they mix the concrete, they combine the different ingredients, and they put inside the trucks, and then the concrete to create the sections. Here are some wires and turns section. They're applying the reinforced steel. Here's the calibration section of the company. Here they calibrate where all the different tendons, strands are going to be positioned. Also, this is a quality control process, so they don't have any objects that shouldn't be there before applying concrete. Here we can see how the concrete is curing. They use different strands. In the company, as I said before, they usually use half-inch wires. You can see some more other pictures of the tension wires before being cut, and the concrete in the curing process. Second stop was Coreslab structures. One of the most interesting things in this company was to see how they created the different hollow core plants. With that machine, we can see the different profiles that.
Are you going to share the presentation, or are you going to cover it entire? I'm just curious.
No, excuse me.
No, are you presenting?
No, no.
You have shared, right?
Yes. Okay, as I told you, here we can see the hollow core plank machine. When we were in the visit, we could see some problems. We saw some more other details pictures in other presentations. When I was there, I asked the person, the engineer that was there, what was the problem happening there. They told me that it was a problem with the machine, that it got stuck and that part was completely ruined. So they just cut and use the part that is available to be used.
Yes,
That's what they said before. It was also curious how they put on the end of the wires these bolts just for safety. I didn't see that on other companies, so this is a good thing to have in mind. We also see how look the reinforced steel before applying concrete inside the molds. This is how they look, and they had this inside. When they did the presentation, this is the procedure stacking, so they reduce the amount of breaking or damages of the beams.
But this is a very practical issue.
The last plant that we visited is Dura-Stress. This company has a big plant which produces different sections for bridges, parkings, and so on. Here we can see I sections and double T sections. Here we saw a pretty long I-beam with pre-tension tendons. And here I just shared the video. They have their own trucks for transferring their products. I don't know, it's not playing. I just shared the video to see how they transfer long I-beams. I don't know how. I think it's not connected. Yeah, it's pretty long. I just they just transferred their products in early morning, I think.
That's a big deal.
Yeah. I think it's a big. And the other truck. Yeah. And Dura-Stress is the only company in Florida which produces a curved beam. Here is some pre-tension mold for pre-stressing the tendons. Here we can see tendons and straps for a beam, and again I uploaded a video for pouring the concrete in this beam. They use SCC which spread by its own weight in the beam.
We had a presentation by Dr. Stefan about SCC, right? So that you could see that how SCC reduced, the work at the site. It's very effective.
Yeah. Oops. Here is a post-tension section for the, again, curved beams. Here are the cranes for moving objects in their own plants. Here they store and mix their material, aggregates, cements, and so on. And here are the questions for.
I'm gonna explain the questions. We piled up all the questions, maybe 6 or 7. The first question is, our goal is to have an optimum design. Is it possible for the company to design a personalized section for the contest? And the second question is the unit price of 7-wire this is not a question. Yeah, it must be a question, but I was wondering the compacted 270K strand, the price of this strand. And our third question is, our beam is going to have a light concrete. What would be the minimum density limit?
Okay, so let's go one by one. Can you repeat that?
From the first question, beginning, right? Is it possible for the company to design a personalized section for the contest?
I have no answer yet.
Yeah, and
well, that's something that we definitely want. But what kind of section are you?
our section, we designed our section, which is I-beam, but it's not symmetrical, like 10 for top, 8 inches for bottom.
Okay.
And I put the thickness of the top and the bottom, and the top and the bottom part as a 6 inches, and the height of the beam is 24. I was trying to do the measure like 1 foot, half foot, because it's easy to make it, I think.
So then, for your group and also the other group, can you refine, because many group, all groups will have this kind of question, right? So can you guys refine more, your questions more, so that when we invite the engineer here, then, because the customized can be anything, right? So then we need to have a more precise question, so then they can answer better.
We can ask them like, we're gonna design a nice shape with these dimensions. Can you do
with
that?
those
Yeah.
dimensions, and so that, because that is actually an important thing, right? Yes, let's refine this question. How about the second one?
It must be a question, but I think there must some error. What is the price of the 7-wire compact 27K strand?
I think we should have a list of products with the cost, right?
Yeah.
So that you want to have a.
Because we want to use, for example, if you want to use this strand, which is more effective, I guess, more than.
Why you chose this strand?
Because we researched 3 types of strand: stress relief, low stress, and the compacted. Compacted has less void inside the strand. They compact the strand, so there is it's more it's more compacted. There is no
It's already explained.
yeah. For example, in the low stress or the relief stress, the strands there are 7 wires, but in the compacted one, the wires are more.
Close together.
Yeah, close together. Yeah, exactly. Thanks.
So then, did you compare? Do you have a comparison of using this strand and then other 2 strands, right? And then, did you see any difference in your design?
Not yet, but I saw a table in the PCI handbook that was explaining something about the forces, but I don't remember right now. But we didn't use that force yet. I think we're gonna use in the shear design or something like that. I don't know. But we still use the 270 value. I don't know yet.
I think maybe in your final report, if you compare 2 different strands, and that will be, I think, a big plus. Because not only me but other engineers will grade your report.
Okay.
And then if you make a comparison, I think not only your group but also other groups, then that will be good.
And the third question is, our beam is going to have a light concrete. What would be the minimum density limit for the Prestressed beam? Normally the density of beam is 150. We used 120 lb or feet square.
So light concrete.
I saw some examples on the website. Some of them used 100, some of them used 115.
Light concrete with Prestressed.
Yes. Actually, this must be fit prime 3, not square.
Light concrete usually have a less strength, right?
Yeah.
In fact, the light concrete, they also use a light aggregate, which is weaker. So I don't know if this is very common, but I'm just presuming that this would be like a cracking issue.
Cracking issues.
So you have to think about that.
Okay.
But in fact, that you have freedom to choose. But I'm not saying that this is wrong. This is I'm encouraging new idea. Okay. So then, why you want to reduce the weight?
Weight is always like enemy of the building.
but comparing with the level of load that you have,
Yeah.
compared to the level of load, your weight is what percentage in terms of the moment?
I didn't calculate the weight.
I think you have to see the trade-off. So then you want to calculate the dead weight with the light concrete and then normal concrete, and then how much you can reduce in terms of moment. Right?
Yeah.
That's something that you want to double check, right? So then if this is very small, then using the lightweight concrete is not really beneficial to your
Okay.
purposes,
Yeah.
right?
Yes.
So, or instead of using the light concrete, then you may use a stronger material. Another way to do it is stronger material, so that you can reduce the cross section, then you can reduce the weight, right? It's another thinking point. And if you want to try, because I'm actually I'm not sure yet because I haven't get the confirmation, but I'm actually gonna invite someone who is the expert in the admixture, so that we're gonna go over the all different, because admixtures there are many different kinds, and there are new products out there, so then we want to know what is newest on the market, and then we may try those if we have a chance to do it. So that I think those are some other dimensions that you guys want to think about. Is there any group who wants to use SCC? Yeah, think about that, and then what you need to know the material properties, right? So then those are something that you got to think about. So there are many things. Okay, go ahead.
I think you explained the fourth question. I'm passing.
Okay. Fair enough.
What is the recommended to lower APS? I think it's area of steel, prestressed steel, reducing strengths. What you recommend to lower our APS and have a more effective design?
I want to ask you guys, what do you think about this question? What do you think?
I don't know. I was the one doing that part, and I have issues when I was checking the beam. The APS always was high, so I was changing the wires, the number of wires, so to see if I was able to change something. But I was always in the same limits, also because the sections that I was using were like over-designed for the purpose that I was using. I was using the asphalt. So I did that question because that was driving me crazy, that I wasn't able to check on that point.
What is your checking force?
I don't remember right now.
I can check it. It's in my bag.
You have
I think let's do not go too much in detail today.
okay.
But so what happens if you reduce the strength in your calculation?
I still was too high, but I don't know if
High means
like the amount that, because on that part you have to check is if more or less than, I don't remember, I think it was FC. But mine wasn't checking somehow, like on some points. I don't know if it's was because of the section that I was using at the beginning was too high, and I was trying to.
No, I mean,
to
to try to
lower.
understand your question, so then high means you have a very large APS?
No, I wasn't fulfilling the condition on that point. I was always over the amount of that was.
Oh, so then it's over reinforced, you mean?
Yes, I don't know. I wasn't checking on that point. I wasn't fulfilling that condition. See, probably it was over reinforced or. Yes.
I think we will have a large compression at full section, and we will have no tension and a large compression at full section. So I think it's not protective.
Yeah, I get to see more detail about your design, but why don't you come to my office?
Sure.
We can talk about that. Is there any other group having the same problem? Not yet? Yeah, because I know that, it's this and, this APS design, the strand design, and the cracking at the anchorage reinforcement will be the next. So then we'll have today I will assign you homework. All right? So then, this is something that you have on that part. That's what I do. All right, go ahead.
And is there any preferred stand section concrete in order to lower our cost without affecting the design? I think we talk this.
Very broad.
They have the experience. So.
Okay.
What is the material properties of your products?
Okay.
And what is the relative humidity in your plant?
Okay. Did you find the answer? Not yet.
Answer?
Did you find the answer?
No. And I have two more questions.
Okay, go ahead.
When we are designing our I-beam, like I was wondering because in our I-beam the thickness of the web I put 4 inch. I don't know if it is too small or not because it can be there can be a slender issue.
Slender?
Or not.
What do you mean slender issue?
Like the I-beam is gonna be like this, right? The web, the shape of the web is gonna be like this. The orientation is gonna be like this on the under the load, and like if it is too thin, the web. If the web was too thin, is there any issue with that?
Oh, you mean like
the web?
The moment to the side. Is that what you're saying?
Yeah.
Well, this is a more like a design problem, right? The victim content is design problem, so that you already know your loading condition very accurately. I think this is something not happens in the real project because your loading condition can be much more complicated in real life, right? But in this big beam contest, you have a very, very precise load condition. And your design is actually targeting for that. So this is a very special design problem. So I think competition, the main point is by knowing your load condition very accurately, and you want to come up with optimal design in 4 different aspects. I think this is a main goal of this.
Yeah, that's.
So there is no the side moment, right?
No.
So then, I'm not saying that the 4-inch thickness is good or bad, but if you worry about the side, then if there is no load, then why do you worry about it? For this,
Because I checked the initial load, initial stress, and the service load. Like we check all the analysis. There is no any issues about with
but
that
one
section.
thing that we have to think about is it depends on your reinforcement. If you have a not aligned anchor location, you could have some problem, right? And obviously, I don't think that we're going to have that much, the misalignment in the construction. But if you have some error there, that could be a problem. Those are the things that I think about. Any comment? Other comments, questions? No? All right, then thank you. So I really appreciate those groups who gave us a presentation, because this is very helpful for those who couldn't go. Okay, so this is very important. And now what I'm going to do is I will share this through through this, in this class, everyone, because it's recorded and then everyone can see. And also, as I said, I will share this to the plant engineers, so then they can get the feedback. And as I said, we have about a month to complete this, so then from now on, we'll be quite busy. So now I think you've been collected, the different pieces about understanding the concepts and so on. Now you have a much clear idea about how to approach this problem. So the lecture-wise, we only have the ultimate strength design, and then a shear strut design. That's it. So then I think we can complete that within 3 lectures, which means that end of next week. Then the lecture, so this is all the things that you need to know about, in terms of lectures, okay? So then now we have to really make a design. So the assignment today I will issue, it will be, we haven't done the detailed strand design yet, and also the anchorage design. So then that's what we're gonna do. So this is also the good chance that for those, the rectangular cross section is, I don't mean that it's bad, but I think to me it's quite boring. Right? I like rectangles, but so think about that, all right? Particularly who has many members. Think about it. And so then that will be due in a week, and then after that, and then I will assign the ultimate strength design check, and then shear design. So then those will be the 2 homework from today, right? So then, and then I think by that, after this, 2 more homework, then you will have a quite decent design, right? And I will actually invite people from the FPCA and also the other factory plants about to give you a more realistic idea of design, so that you guys can have help when you design your beam. Okay.
So the next 2 homeworks are on what? On the shear?
So then I forgot the homework number, but the homework I will assign today will be tendon design, right? And then anchorage design. And then that will be due in a week. And then the next homework will be about ultimate strength design. So the idea is you have a ASD, right, a lower stress design, and that you want to check in terms of LLFT. So then if your design is okay, then it's okay, right? And then you will design the shear struts, right? So then that will be actually the main part of your design. Right?
Is it group assignment or?
There will be group assignments.
You mean the ultimate design we did not come to, right?
That's what I'm going to cover from Thursday by end of next week. All right?
And also the tendon design, you said like the envelope design? Or?
What you have done is envelope, right?
Uh-huh.
But we need to finalize the positioning, the tendons, right? So what size of tendon you're gonna use, and then where you're gonna put, and then what anchors you're gonna do, right? So then that's what you're gonna do in the next week. And I think this is a good time to you guys start thinking about your report format. We're gonna have a professional report at the end. And I will send you the survey form to everyone. And so then I will, once I collect it, I will actually give that to the plants. Okay. All right, that's it for today, and then I will see you on Thursday.